Okay, so I did email the notes. I want to post videos as soon as I can. Working on that. All right, but basically now what we're in is we're in chapter 2, section 3 on lines, and what we saw last time was slope. Basically, if you have 2 points on a line, 2 different points that is, and the line is not vertical, and because they're different and they're not vertical, we can assume the x coordinates are different. We can then calculate the slope. Basically, it's change in y over corresponding change in x. And as you can see, I did write this in the definition. But what I like to do, because unfortunately with subtraction, you do have to be careful. And what I like to do is I like to make sure the x and y coordinates on top for the same point are on top of each other, like this. That's what I like to do. I know there is something called rise over run, which is also really good. Okay, so again, coordinates for the same point, they're on top of each other, on the same side of the minus signs, if that makes sense. We will actually see later today, actually, where even without doing any calculations or graphing, by just considering 2 different points, you're able to determine if the slope has to be positive or has to be negative. It's actually not hard to do that, but you'll see what I mean later on today. And then we did some examples like here, and I figured now, we'll get to that, and I figured now it'd be good to do more examples. I was originally going to have people work on this and try it out, but for the other class, I did not do that, and I want to keep everyone on the same level. So let's just dive right in. So here, for instance, we're going to find the slope of the line through 2 different, so we're going to find the slope of the line through each pair of points here. So for 1, -4, and 5, -2. Again, what do? You subtract the y coordinates like so. And we're also going to, and you're going to divide by the corresponding difference in x coordinates, like so. Okay? So, right, and again, coordinates for the same point, as you can see, they're on top of each other. Okay? For -1, they're on top of each other. -2 and 5 are on top of each other. All right? Now, and what do we get here? Well, we get -4 plus 2, which is -4 minus -2, right? -4 plus 2. We have 1 minus 5 down here. We get -2 over -4, which is a half. And we do the same thing down here. As you can see, we have 3 minus 0 over 0 minus 3. Again, there's coordinates for the same point are on top of each other, as you can see. Okay? So we have 3 over -3, which is -1. But notice also that with these 2 points, x is increasing. So the x coordinate gets bigger from this point to this point. Here, the y coordinate also gets bigger. So the x coordinate gets bigger if we go from this point to this point, and the y coordinate also gets bigger. That's how we know, even before doing this, that the slope, whatever it is, it had to be positive. That's why the slope had to be positive. So if we somehow messed up and got negative a half, then we would know something's wrong. Here, though, if you went from this point to this point, I mean, it really doesn't matter which ones, from here to here, right? Notice that our x coordinate is getting smaller. It's dropping from 3 to 0. The y coordinates are going in the opposite direction, so to say, in that they're increasing. So from one point, you have from this point to this, you have the x coordinates are getting smaller, but the y coordinates are getting bigger. That tells us the slope has to be negative. We'll see this again, but really this is how we can tell if a slope is positive or negative. And that's very useful considering with subtraction, you have to be careful with the order. All right, so here's another example. Here we have this line. We want to figure out the slope of this line. Now to do this, we really just need any 2 points on the line, any 2 different points, I should say. Now really, you can use any 2 points you want. I chose this point, -3, -1, and this point, 3, 4. Now, I just chose these 2 points. I mean, really, you could choose any 2 points. You could choose this one over here, which looks like it's 0, 1.5. Other points you would have to estimate a bit because you can see they're not directly in nice places, so to say. But to get the slope, once you have 2 points, right, you just, do the calculation. Notice also, even before we calculate, although I guess I kind of gave it away, but notice that your x coordinate is getting bigger from this point to this point. And the y coordinates are also getting bigger. Here the x coordinate goes from -3 to 3. The y coordinate also follows the same direction, so to say, in that it also gets bigger. That's how we know this line has to have a positive slope. And the calculation confirms that, right? Because again, what you could do is you could do change in y, -1 minus 4, over the corresponding change in x, -3 minus 3. So we have -1 minus 4 over -3 minus 3. As you can see, -1 and -3 come from the same point. They're on top of each other. 4 and -1. No, excuse me, 4 and -3, excuse me. They're from the same point, so they're on top of each other. I was about to say 4 and -1 were from the same point, but that's not true. So, but we get a positive slope. We get -5 over -6, which is 5 over 6. So we get a positive slope. All right. Here we just have another example that I want to go through. This will help illustrate what I was trying to say before. So here we have 2 lines. One line is green. The other line is blue. Okay? And we can see that the green line, which is first, that passes through points 1, 2, 2, 4. The blue line goes through 1, 2, and 2, 6. So for 1, 2, and 2, 4, as you can see, okay, that slope is what? Well, you subtract y coordinates over corresponding x coordinates. So we have 4 minus 2 over 2 minus 1. Again, same coordinates from the same point. They're on top of each other. Okay, they're on top of each other. They're on the same side of the minus signs, of the subtraction signs, if that makes sense. And you can see that we get 2 over 1, which is 2. And for the other line, the blue line, it's similar, except instead of 2, 4, we have 2, 6. So we have 6 minus 2 over 2 minus 1. And that's what's happening here. 6 and this 2, they're from the same points. Coordinates of the same point. 2 and 1, they're also from the same point. So we have this. Good. Okay. And from here we get 4, as you can see. But notice, though, both of these lines have positive slope. And notice also that the lines, as you're moving towards the right, meaning as x is increasing, so as we're walking along the x-axis to the right, looking up, we can see that the lines are rising. Both lines are rising. You know, you can imagine walking along the positive x-axis here, and while you're walking, you're looking up, and the lines you can see are rising. That's because the slope is positive. That's what happens with lines that have a positive slope. So lines with a positive slope, as you're moving to the right horizontally, that is with x increasing, these lines, okay, are rising. Mostly because what's happening is the y-coordinate, which represents height above the x-axis, that's increasing. Okay, so if the line's rising, it's positive slope. Notice also that the blue line here, as you can see, this line has a bigger slope. This is the line. The slope is a lot bigger, it's 4. The green line has slope 2, and the blue line is steeper. In other words, it's more vertical. And that's what's going to happen in general. Basically, the bigger the slope is, the more positive it is, so to say, the steeper the line's going to be, the more vertical it is. I mean, what's really happening is that it's increasing at a faster rate, the height that is, so that's why it's steeper. Okay? And we could also see, even without graphing it, that it had to be steeper. It had to be positive, because again, if we go from this point to this point, meaning our x's are increasing, the y's are also increasing. That tells us right away, right, that the lines have to have positive slope. Okay, let me just stop the recording because I'm running out of time here.